Okay, so in this video I will add the UART and CANbus here, and I will use this STM32 CubeMX software to select correct pins. So we can start by going here, and then from here we can go to this FDCAN and click activated. So now it will propose some pins here, and if we press Ctrl and click this pin, we can move it to some alternative pins. So what I want to do, I will actually move them here, and we can now go to this KiCad and select those. So we can see this PB9 was this TX for transmitting. So I will go to this MCU sheet, and then I will create this hierarchical sheets from here. So the output was this CANTX, and it was this PB9, and then we can Ctrl C and Ctrl V to copy that, and I will place this RX here. I will now double check if those were correct. So yep, that was correct. And then we can add this USART. So I will be using this USART1. Double check. Yep. So I will use this USART1, and it will work as asynchronous, and it will again place some pins. And if we look here, this PC4 and PC5, we can check where they are. So they are on the, they are here. So there are these 21 and 22 pins. And if we check where those are, it's here, and it's not a good idea to place these UART pins here because we have all these analog circuits here. So we don't actually want these high-speed digital signals here. So we will check some other place if we can have them somewhere here with these other digital signals. So we can go here, and then pressing again Ctrl, and we can see that it's accessing this PA9, and for this one, this PA10. So these are actually, we can go here and check the PA9 and PA10, they are here. So they are actually next to this USB lines, which is good. So all these digital signals are basically here. So what I do, I will Ctrl C and Ctrl V here, and I will rename this USART1 RX. This was TX. And this was input. I will check if those pins were correct. So PA then is RX. So it should be here. And we can draw these lines here. I will double check this PA9. So it's, yes, this TX. And we can save this, and we can go here and by right clicking there is the sync selected sheet pins, and it opened this window here, and I will press shift so we can have all these and add sheet pins. And now we can have this hierarchical box here. Let's add this here, can be somewhere there. So those are fine. And these are actually, I will leave them like here now, but I will create this kind block as here for this USB and this SVDO, and then it will be connected here to these pins. But if we go back to this layout, add some resistors here. Yeah, so they are actually for this USB CC1 and CC2 lines. But as we can see, this USART1, TX and RX, they are here, which is good. And then this other line, this CANbus BB8 and BB9. So they are here. I will actually remove this one from here. I have to check the correct routing for this, because now I think that this reset MCU pin was actually needed for this flashing system. So I have to check how to configure this properly, because they are basically sharing the same pin. Could be on PD0 also. Was there that pin even here? Yeah, well, I think that should be fine. It just needs some, because it's the receiving end, so it will just need some kind system when it will ignore this rest pin. Yeah, we can go on this layout side and do some work here. So I'm planning to do a little bit this analog circuits more now. So what we can do is that we can have this. I will, by pressing U, I can highlight this whole wire. I will drag this somewhere a little bit here. Actually, I will move it a little bit more here. Let's see. From here we can rotate them 45 degrees, and by pressing R we can rotate 90 degrees. So these are somewhere here. Yeah, I think that should be fine. I will probably move this analog circuits a little bit even more closer here because there is so much space now. And for this, let's see. For these inputs I might even route them because they are ADC input for like control. So I think I can even route them just from here. Let's see what would be a good place for those. If it was some very sensitive signal, it would be better to route them here, but these input signals, they have these very big capacitors here, and I will anyways filter them a lot of on the firmware side because they are very slow control signals, so I will just route them as this, and then they will be routed somewhere here where is the connectors for those. More important is that this analog current sense signals have good, bad, and not much noise there. So everything here is basically for this analog signals. Only thing here is this oscillator, which is kinda close of this part, and it might be good to move them like a little bit further here to get a little bit more spacing. Or I can just also, let's see. I can also make them more spacing this way. So I will move those somewhere back there. This should be totally fine. And for this, I will usually like to do this thicker trace. And then by pressing V, we can do this via here. And I'm actually routing these signals as differential pair. I can show how that works. So we have to hold, click here, then I will actually remove this small part here. So now we have this selected and we click there. And what I have been doing, that I want to route this current sense signals on this bottom plane, so they are like basically as far as they can be from all these noisy power electronics. So I will click here and I will route them. For now I also have this vias here. They are basically acting like this kind guard tracing for the analog signals, but I might remove those vias because I think they are not really even needed for this application. I will also do same thing here, so I will, for now I will remove those. I will route these again, so they can go somewhere here, so that should be fine. Yeah, I think this is enough for this video. Thanks for watching.